everybody. Let's do solutions to problem set 1. The first problem is the distance formula, which is here, and the distance formula in two-dimensional space is the square root of the difference in x coordinates squared plus the difference in y coordinates squared. I was suggesting that we program by intention, which means imagining a method that computes the thing that we want to compute. But you'll notice that we haven't actually implemented the method so that it does anything yet. So we'll start with that. We'll have all the code in place that will display the output for some example inputs so that we'll know it works. But then only after we have all of that in place do we actually implement the method. So here we go. I'm going to type a little bit slowly and narrate what I'm typing. You can always set the video to double speed or even faster if you would like. I want to print the result of running a distance method. So I'll do SOUT, and then I'll hit tab, and that will autocomplete to system.out.println. And now I want to compute a distance, but we don't have a method to do that. So in programming by intention, I will assume I have a method called distance, and because I'm inventing this as I go along, I get to decide what the inputs are. And so I think the first two inputs will be the xy coordinates of the first point, and the second two inputs will be the x and y coordinates of the second point. Let's go and put our cursor on it, and I'll hit Alt-Enter. Oh, and it has automatically imported a different distance formula from a Java package called Point2D that almost certainly does what we want it to do. But the purpose of this exercise is to program it ourselves. So let's actually create the method signature. I'll say public static. We'll talk later about what static means. Next comes the return type. Distances usually return a number that has decimals, so the return type will be double. The name of the method is distance. And now I have the parameter list, which is comma-separated variable declarations. So when I declare a variable, I need a data type, like double, and a variable name. So if this just appeared on a line by itself, you would say, aha, we're creating a variable called x1 that will hold a double. And that's all we're doing here. By putting it inside parentheses, we're saying that we want to declare this variable to hold the input that's the first number that we provide when we actually run the method. So let's now declare all of them. So we'll have x1 and y1, we'll have x2 and y2. I will open a curly brace and hit enter. Let's zoom out a little bit here. And so you can see the red underlining, which is called a compile time error. The compile time error has gone away because now we're able to run the distance method and have it accept 4 inputs. It'll run that method here, and 0 will get assigned to x1, 0 gets assigned to x2, 2 gets assigned to y1, 2 gets assigned to x2, and 2 gets assigned to y2. All right, there's still an error here, and if you hover over it, it says missing return statement, because putting double here says that our method needs to return a double, but we don't actually ever have a statement inside which says what it should return. Okay, here's my favorite way to do this. I'm going to define dx, which stands for difference of x's, and that's going to be x1 minus x2. I'm going to define dy, which is y1 minus y2. And now if I wanted to, I could define distance, which is going to be our final answer, and that'll be math.random, math.sqrt for square root, capital M on math, by the way. And now I'll do, so some students will do this. This is wrong, what I'm typing right now. In some programming languages, this will square the input. In ours, it does not. The best way of squaring a number is just multiplying it by itself. You can also use math.pow, but that runs much more slowly. So I would recommend just dx times dx and dy times dy. And then you can return dist. It's a little bit silly. You might notice that IntelliJ is highlighting this. It says local variable dist is redundant. And that's because we don't ever do anything with it other than return it. So there's really no point in naming it. So what I'll do is I'm going to cut this expression, and I'm just going to put it right there in the return statement. And so now I don't actually store the answer in a variable before returning it. I just return whatever the expression was. All right, let's go ahead and run it and make sure it works. So here you can see what it thought the distance was. You can hand check that on the calculator if you want. Another nice way to check things is to give it coordinates where you know what the answer should be. So if I'm going from 0, 0 to 0, 2, we know that the distance should be 2. And indeed, there it is, 2. Okay, let's do problem 2. Okay, in problem 2, we need a method to calculate the area of a triangle. But rather than being provided with a base and a height, we're going to calculate it if we're just given the 3 side lengths. And it says, let's assume the inputs define a valid triangle. There's no need to check them, which in general is not true. Like imagine I gave you the numbers 1, 1, and 100. If you sort of if I asked you to draw right now a triangle whose side lengths were 1 and 1 and 100, pretty quick you will discover that that cannot possibly make a triangle. But that's not the point of this problem. The point of this problem is just, can you take an equation and kind of imagine how would you render it in code? So the equation I see, I need the square root of this stuff. Here, let's do this. I'm going to go ahead and delete my running of the distance method from main. I'm going to keep the method here just as a record of the work that we've done. But now let's program by intention by printing out a method called area, where I'll give it 3 numbers like 3, 4, 5. And it should return the area of a triangle. I'll hit Alt-Enter, and now it says create method, area, and main, and that's what we want to do. So that defines the method signature. But I don't want it to return a Boolean. I want it to return a double because it represents an area. And then even though I gave it integers as the side lengths, 3, 4, and 5, it would be nice to have this work with any side lengths, not just integers. So I'm going to change this to double, and I'll call that A. I'll change this to double, and I'm just hitting enter. I'm not using the arrow keys, I'm not using the mouse. So double, enter, B, enter, double, enter, C, enter. And notice the cursor has now been placed inside the curly braces, which is exactly where I want to be typing. So again, in the interest of speed, try and take advantage of these shortcuts rather than using your mouse or your keyboard to navigate. All right, so copying straight from the equation in the problem here. Let's try and get them on the screen at the same time. All right, so I want square root of s times s minus a times s minus b times s minus c. So if I wanted to, I could just do that. I could say, let's return math.square root of s times s minus a times s minus b times s minus c. Let me show you the equation again. You can see them side by side. So hopefully you can see math.square root represents the square root. And then inside the parentheses, I'm doing all these multiplications, the s minus a, the s minus b, the s minus c. The problem is, you see this red highlighting here. If I hover over it, it says cannot resolve symbol s, because a, b, and c are the 3 input numbers, but we haven't defined s yet. So s is the semi-perimeter that's defined by this equation. So let's go ahead and do that. I'm going to do something a little bit wrong, and then we'll fix it. So we'll define a variable s, which was a plus b plus c divided by 2. This is wrong, what I'm typing right now. You can see a plus b plus c divided by 2. The problem is order of operations. So because division happens before plus, in computer language, we would say that it has a higher precedence, which means that it executes before something else. So we don't want to have a plus b and then do half of c. Instead, we want, just like you would in math, you would want to use parentheses to group together the operations you want to do first. So we'll add them together first, and then we'll divide by 2. And I think we're good now. So we can just run the code and verify that it works. Okay, so area of 6, and you can check by hands to make sure that that makes sense. Okay, problem 3 says we want to roll 2 6-sided die, but we're going to simulate that by using math.random. And then we're going to display a line that says the value of each die and what their sum is. And then that's going to happen 20 times. Okay, so let's try it. I'm going to delete the last problem. This problem, it doesn't say to make a method, but I'm going to make a method anyway. I'll just call this problem 3. And this time, I'm not going to print the return value because I don't want it to actually return anything. I'm just going to have it run the entire problem 3 for me. The reason I'm doing this is so that way I'll have a record of problem 3, but when I do problem 4, I can delete the running of the method. And so I'll still have a record of everything I've done, but I still have main available for testing the problems that I want to test in the future. All right, so what do we want to do? I'm going to start... So some people might start from the beginning and say, well, what we need to do is we need to roll two-sided die, and then two six-sided die, and then eventually you get to the idea that we need to do it 20 times. I'm going to start with the idea that we need to do something 20 times. So I'm just going to write a for loop that loops 20 times. The hotkey is for I, and then you can hit tab or enter. I is a fine variable name because we're just counting how many loops. And I want to do it 20 times. So if I start from 0 and I go up to I is less than 20, that will be 20 total repetitions of what's inside the curly braces here. I know I want to print something, so I'll print. And let's say die1 is, and then I'm imagining val1 is going to be the value of my first dice. And then die2 is, and then val2, and then a dot, a period, and then their sum is, and then I'm going to have sum here. So I'm imagining everything I need to display, only the values that change, I'm imagining variables. And right now I'm going to go back and actually create those variables. So here I'll have int for val1, and let's come back in a second and actually initialize it. Here's an int for val2, and then I'll have sum equals val1 plus val2. Okay, so and the reason these are underlined in red is because I've declared them, but I haven't given them values yet, and you can't add things together that haven't been initialized. All right, so let's do die rolling. I'm going to do something a little bit wrong, and you can think about how it's wrong. So at first blush, it might seem like this is going to return a number between 0 and 6. Oh, whoop, I said the wrong thing already. It might seem like this is going to return a value that's random up to 6. There's two reasons this is wrong. The first reason is it's possible that this would return 0, and that's not a marking on an ordinary die. So we don't want it to be possible for it to return 0. The other problem is it's not actually possible that this will output 6, because math.random is any number between 0 and not quite 1, so like 0.999999999. But in order for the value 1 here to be 6, math.random would have to be 1. That's the only way that we would multiply a value by 6 and have it end up being 6, was if this value was 1. So I'm going to fix both problems at the same time. I'm going to say 1 plus. So the smallest thing this could be is 0. And if this were 0, I'm going to add 1 to it to make 1. And so that's like the new smallest value. And that's what I want, because the smallest value on a die is 1. The largest thing the highlighted portion can be is 5. Because if I have, let's say math.random is the largest thing it could be, like 0.99999. If I multiply that by 6, now that's like not quite 6. It's 5.99999. If I cast it int, that truncates it, which just means it chops off the decimal part. You can think about it as rounding down, but it's not really rounding, it's truncating. So this entire thing, the largest value it could have is 5. But then when I add 1, that takes me to 6, which is what I want. So I think this is a perfectly fine way to do it. It doesn't matter where you add the 1. You could add it on the outside like this, or you could add it on the inside like this. Or you could add it over here. And it's still going to do the multiplying by 6 because of order of operations. So you definitely want to think through before you just type a thing and understand why are all three of those things actually going to end up being the same. But there's lots of different ways that you can do it. All right, so I've calculated two values. I add them together and I print it. And we're doing that 20 times. Let's run it and see what happens. And then I'll show you. I would prefer to clean this up a little bit. So here we've got die 1 is 4, die 2 is 2, their sum is 6, 4 and 6 is 10, 1 and 5 is 6. Looking down here, I'm noticing I'm getting values of 6, but nothing higher. I'm getting values of 1, but nothing lower. And so that's good, a good spot check to make sure that my math.random statements make sense. All right, to my taste, I would want to do a couple of things here. I don't feel like it's really necessary to have the sum variable, because I think it's pretty clear to just display the sum right inside the print statement. So I've deleted the sum variable. You do need parentheses here to have it do the addition first, but I think that's okay. So now I can get rid of the sum variable. You know, a programmer who's a beginning programmer might look at this and they would have to think for a little while about what is this doing. So a nice thing to do is let's define a method. I'm going to call it roll die. And now a beginning programmer or an advanced programmer or anybody would just look at it and there's no question. They don't have to ask, why are we generating random numbers? They would just read this and say, aha, we are rolling a die. And then here we could also say roll die. But the problem now is we actually have to define the method. So let's put the cursor on the method. We'll hit Alt-Enter. We'll create the method. It should return an int. And now I can paste in the code that I'd cut. So this is the same code that generates the random number, only now we're returning it. And that might seem silly, like why replace one line of code here with like a bunch of lines of code here? And for a problem this simple, you could be right. But as we program, you'll get programs that are longer and longer, and doing this kind of simplification is going to be absolutely crucial to you or anybody else understanding what in the world your code is actually doing. Probably by this time in your programming career, you have written code that has eventually overwhelmed you with its own complexity. And this kind of thing is a technique for enabling you to write bigger and more complicated programs. We'll talk a lot more about it during the school year. Okay, now that I've done that, well, maybe that's enough. So we'll stop there. Good job, problem 3. Is there a problem 4? Nope, that's it. So that was the end of the problems for this week. Come back in the next video to see the problems for the solutions for problem set 2.